GRIAS Academy.
100 days, 100 themes, one goal, UPSC Prelims. Hello all, welcome back to the program Mission Surya Phase 3 of STEM Revision Program, where we deal with current affairs regarding science and technology and environment completely in Prelims perspective. So let us start our today's session. So today, let's start with our first topic. Our first topic is battery energy storage system. What is this battery energy storage system is? It is like a technology, just a second, I'll change the pen. BESS. BESS is a storage technology. It is a storage technology where the electricity is stored in the form of batteries. Stored in the form of batteries and released whenever it is needed. This is the basic function of battery energy storage system. See, let's see the concept of it. A subsequent energy storage that uses electrochemical solutions which are used in batteries to store energy and inject it back into the grid whenever it needed. Okay, next, what is the intermittency problem of it? The intermittency problem of it is solar power peaks at noon. Basically everyone knows at noon, like 12 to 3 between, the solar power peaks, right? So what happened? And wind power fluctuates widely, So BESS, what it does? It acts as a buffer now. Like storing excess daytime energy. The energy which is released in the daytime is stored in this BESS to release during peak evening demand hours. Okay, like effectively flattening the duck curve. You can see the duck curve here. It is in the 6 am where the utility is only, consumption is only a bit, but coming to 9 o'clock to 3 o'clock, when you see, the consumption is very low, right? Because it is the daytime and the energy produced is more and the consumption is low. Comparing to 6 o'clock to 9 o'clock in the evening, 6 to 9 in the evening, these are the evening demand hours where the electricity consumption is more. So the electricity have to come from the grids highly. Okay? No. This is what the duck curve means. It resembles the duck shape, so it is called as duck curve. Generally duck curve we can calculate the duck curve in this formula, like y is equals to d of t minus s of t. Means y is the net electricity that is generated from the grid. D of t is total demand of electricity, and S of T is the solar generation, how much amount of solar generation has happened. By this we can calculate the net amount of the electricity which is coming from the grid. Okay, next, there are few ancillary services like beyond the storage of electricity by using BESS can perform few other functions, like they provide crucial grid stability services like frequency regulation and voltage support, replacing the physical inertia loss when phasing out massive coal turbines. This is one application where the BESS can work. Rather than storage, it can work in this fields also. Okay, now let us see the viability gap funding scheme for BESS in 2023. The nodal ministry for this is Ministry of Power. It comes under the Ministry of Power. What is the target? The target is development of 4,000 megawatts hours of electricity of BESS projects by 2030, financial year 2030 to 31. What is the financial support for this? The VGF scheme for BESS. The government provides up to 40% of the capital cost. 40% of the capital cost as VGF to make battery storage commercially viable. VGF to make battery storage commercially viable. Okay. Next. See, this is a bit important for your prelims fact. make a note of it. A maximum of 85%, a maximum of 85% of BESS project capacity must be made available to distribution companies like DISCOMs. This ensures the heavily subsidized infrastructure benefits, the public grid, not just private commercial entities. Okay, next. This is one major fact. Okay, next. See, let us see a few things. See, as I said, this energy is, this electricity is stored in the form of batteries, right? BES is the storage system of electricity. So, how the lithium ion batteries, chemistry and emerging tech, science and tech section, okay? Generally, we have to understand which industry and why the industry is looking beyond the lithium, okay? Why this manufacturing industry, rather than looking into the lithium, it is looking on to various other batteries also, everyone have to know, okay? Let's see. First, lithium ion. Currently, lithium ion batteries currently dominates due to high energy density and efficiency. However, it suffers from thermal runaway in the sense fire risks and all, okay, and heavy reliance on imported critical minerals. This is highly imported, okay, this is highly imported. Next, so behalf of this lithium ion batteries, we are coming up with vanadium redox flow batteries. Why? Because unlike lithium ion batteries, flow batteries store energy in liquid electrolytes. It stores energy in the form of liquid electrolytes, which is kept in external tanks, You can increase storage capacity simply by using large tanks, not by small tanks. By using larger tanks, we can increase the storage capacity by using vanadium redox flow batteries. Okay, next, what are the advantages of this? It gives zero degradation over thousands of cycles. We have only zero degradation process, making it the superior choice to massive grid scale long duration storage, that is long duration storage up to 8 to 10 hours. Okay, next, this is about vanadium redox flow batteries. Next comes the sodium ion batteries. How are these sodium ion batteries used? These used widely available sodium. Sodium is nothing but our salt. Instead of rare lithium which we are importing, they are used widely available sodium. Okay, while it has a lower energy density, when density is low, what happens? Heavier and larger. It is significantly cheaper and performs better in extreme temperatures also. This is one advantage of sodium ion batteries, which is easily available. Sodium obviously it is easily available rather than importing like lithium ion batteries. Okay, next come the solid state batteries. These solid state batteries replaces the flammable liquid electrolyte, which is found in lithium ion batteries with a solid material rather than this liquid electrolyte material like in lithium ion batteries. We can use the solid material, which drastically improving fire safety.
Improves the fire safety, so fire risks may also decrease, and allowing for faster charging. Compared to the lithium ion batteries. That's why rather than lithium, now various electronic vehicle companies are looking forward for this other batteries. Okay. Now next see supply chain geopolitics and critical minerals. We'll look into it. See the vulnerability. India currently imports over how many percentage? 70% of its lithium ion. It imports 70% of lithium ion cell requirements primarily from China and Hong Kong. These are the two major exporters to India where we are getting lithium ion cells from. Okay. Next. See this Kabul in the sense, Kanij Bidesh India Limited. Kanij Bidesh India Limited. This is a joint venture. This is a joint project which is created by Ministry of Mines to secure critical minerals, to secure the critical minerals assets overseas. Okay. Kabul recently signed agreements to explore and acquire lithium blocks. Explore and acquire the lithium blocks wherever it is available. In Argentina, that is parts of South America's lithium triangle. South America has a lithium triangle, the places where the lithium concentrate production is high. Okay, along with Chile and Bolivia, Chile and Bolivia, okay, and Australia also. So this is a joint venture which is created by the Ministry of Mines to secure critical mineral assets overseas. This Kabul recently signed agreements to explore and acquire lithium blocks in Argentina, specifically the parts of South America's lithium triangle, along with Chile and Bolivia and Australia also. Okay, next, coming to the domestic discoveries, recently Geological Survey of India estimates of lithium reserves in Resi, that is near to Jammu and Kashmir. Resi, a place where in Jammu and Kashmir a few estimates of lithium reserves have been found. Next, and Katgora, which is in Chhattisgarh. Okay, these two are the domestic discoveries which have been happened recently. Okay, next. Now, moving on to our next topic. Our next topic is sustainable aviation fuel. What is the sustainable aviation fuel? This is the sustainable aviation fuel is an alternative fuel for aviation. Okay, this is an alternative fuel for aviation. Okay, so how this is produced? Rather, basically our petrol, diesel, everything is this produced from fossil fuels, right? So to reduce this consumption of fossil fuels for in production of petrol or diesel, now these SAFs like sustainable aviation fuels are produced using renewable and sustainable sources. Okay, renewable and sustainable sources it's been used rather than these fossil fuels. Let's see the basic concept of it. So coming here, SAF, what is SAF? Sustainable aviation fuel. It is a liquid drop-in alternative to conventional fossil fuel based aviation turbine fuel or jet fuel. Okay, now what is this drop-in characteristics? Let's look into it. It means the sustainable aviation fuel can be blended seamlessly with existing conventional jet fuel. The jet fuel which is existing now, it is blended with the SAF like sustainable aviation fuel without requiring any modifications to aircraft engines. Basically, when we are changing the complete fuel, we have to change the engines also, but in this case there is no priority of changing the aircraft's engine or airport fueling infrastructure. There is no need of changing all this. So sustainable aviation fuels must strictly comply with ASTM international standards. Okay, ASTM international standards to ensure flight safety. Okay, see, what is the raw material which is collected? It is the cooking oil, household and agricultural waste which is being used. These are the renewable and sustainable sources, right? Now, this is the feedstock for sustainable aviation fuel. This sustainable aviation fuel is now blended with the traditional jet fuel. This traditional jet fuel then it comes for the distribution at airports and into aircraft wings. This gives what? Lower emission flights using SAF, sustainable aviation fuel. Okay, means see, on an average 70% reduction in carbon dioxide from flights using sustainable aviation fuel. By using sustainable aviation fuels, the emissions from the carbon dioxide which is emitted from the flights is reduced to maximum, it will be reduced to maximum of 70%. Okay. Next, this is how the sustainable aviation fuel works in the aircrafts. Now, next, let's see what is this carbon neutrality loop. Carbon neutrality loop. This, see, unlike fossil fuels that pull deep earth carbon into atmosphere, which pulls the deep earth carbon into atmosphere, the sustainable aviation fuels are produced from renewable biological sources or captured carbon. Okay, the carbon dioxide emitted during flight is roughly equal to the carbon dioxide absorbed by the biomasses, during its growth, creating a closed loop carbon cycle. Okay, next, depending on the pathway, this sustainable aviation fuels can achieve the greenhouse gas emission saving of up to 94% compared to standard petroleum derived jet fuels. This is what the whole concept of carbon neutrality loop. Basically only one thing, by using this SAFs we can reduce the greenhouse gas emissions, so that all the on compared to standard petroleum derived jet fuels. Okay, next. See, let's see the feedstocks for it and production technologies. Generally, UPSC frequently tests the generations of biofuels, generations of their source materials, their biofuels and source materials. They will ask in the examination to trick you. Okay. Now, let us see, there are three types of generations: first generation, second generation and third generation. What are in this first generation? They are used in first generation. So, the raw materials which are used are sources are sugars, starches and vegetable oils. These are often debated due to the food versus fuel conflict. Okay, this is one of the drawback of first generation. Next, coming to the second generation, non-food crops, agricultural residues like stubbles, like forestry waste and used cooking oil. India is heavily prioritizing 2G feedstocks, second generation feedstocks, to avoid food security issues, to avoid, unlike first generations of biofuels, the second generation of biofuels are mainly prioritized in India to avoid food security issues. Okay, what is in third generation? In third generation we have been using algae based fuels. In third generation we are producing algae based fuels. Okay, next, these are the three generations of biofuels. Now see the key processing technologies. See, hydroprocessed esters and fatty acids. The most mature and widely used commercial technology globally. This is most commercially used technology globally. It refines the vegetable oils, animal fats and used cooking oil. It refines vegetable oils, animal fats and used cooking oils. Next, alcohol to jet. The second thing is alcohol to jet. This converts alcohol like ethanol, basically the ethanol which is produced from sugarcane or the agricultural waste, into jet fuel. What it does? It converts the alcohol, that is the ethanol which is produced from the agricultural wastes and from sugarcane, into jet fuel. This is of alcohol to jet, ATJ. Next is PTL, power to liquid or synthetic fuels. Power to liquid or synthetic fuels. It uses renewable electricity. It uses the renewable electricity to separate hydrogen from water. To separate the hydrogen from water, it uses renewable electricity, combining it with captured carbon dioxide. The carbon dioxide which is captured is being used to create e-fuels. Okay. Next, these are few processing technologies. Next, coming to the international framework and regulatory framework, we can see the Carbon Offsetting and Reduction Scheme for International Aviation, CORSIA.
It is the international regulatory framework. What is it? The carbon offsetting and reduction scheme for international aviation. What is the governing body of it? The governing body is International Civil Aviation Organization. It is a UN specialized agency. International Civil Aviation Organization is a UN specialized agency. Okay, next, what is the core objective of this CORSIA? It's to achieve carbon neutral growth. To achieve the carbon neutral growth for international aviations. To achieve carbon neutral growth for international aviation starting from the baseline year of 2019. Starting from which baseline year? 2019. Okay, what is the compliance now? Coming to the compliance, to be eligible under the CORSIA framework, a fuel must demonstrate life cycle GHG emissions, greenhouse gas emissions, that are at least 10% lower than the petroleum jet fuel baseline. It has to be 10% less than the petroleum jet fuel baseline, and must not contribute to the conversion of land with high carbon stock. It should not, the basic point is, it should not emit more greenhouse gases. It has to be less than the 10% less than the petroleum jet fuel. Okay, that's the compliance. Next, what are the phases? The scheme has shifted from a voluntary pilot phase from 2021 to 2023 to increasingly mandatory phases. Okay, see, CORSIA means the carbon offsetting and reduction scheme. The carbon offsetting and reduction scheme for international aviation applies strictly to international flights between participating member states, not domestic aviation. It is not between the domestic aviation, it is strictly applied to international flights between practicing member states. Okay, next, moving forward, see, what's the Indian policy now? We have seen few international policies, right? Let's see the Indian policy landscape and targets. What are the targets? Basically the target years and percentages are the prime targets of statement based questions in your UPSC examinations. So please have a look on it. Now first is national blending mandates. National blending mandates, which comes under the Ministry of Petroleum and Natural Gas. Okay, this is what means 1% of SAF, sustainable aviation fuel, 1% of sustainable aviation fuel blending target for all international flights departing from India by 2027. This is the first one, like in national blending mandates. Okay, the next thing is 2% of sustainable aviation fuel blending target for international flights by 2028. By 2027, how much percentage of SAF is being mixed? 1% of SAF is being blended for the flights moving from 2027. For the flights, for the international flights moving by 2028, how much of SAF is being blended? It will be blended by 2%. Then the 5% indicative target by 2030. 5% of indicative target by 2030, India is going to achieve. Okay, now let's see the domestic technology development. The domestic technological development. The Council of Scientific and Industrial Research, the Council of Scientific and Industrial Research, Indian Institute of Petroleum, CSIR IIP, has indigenously developed a single-step catalytic process to convert non-edible oils and used cooking oils into SAF, sustainable aviation fuels. What they did, indigenously they have developed a single-step catalytic process to convert non-edible oils and used cooking oils into sustainable aviation fuels. This is done by the Council of Scientific and Industrial Research, Indian Institute of Petroleum, that is CSIR IIP. Okay, next, Global Biofuel Alliance. This is launched by India during its G20 presidency summit. Okay, the GBA aims to, the Global Biofuel Alliance aims to facilitate global technology transfers and standardized certification for biofuels. For global technology transfer and standardized certification for biofuels, directly supporting the sustainable aviation fuel supply chain. Okay, this is what the Global Biofuel Alliance is, and this is about the domestic technology department, which we have produced, which we have indigenously developed a single step catalytic process to convert non-edible oils and used cooking oils into SAFs. Okay, next. So moving on to our next topic, small modular reactors. What are the small modular reactors? These are the nuclear reactors basically. Generally, nuclear reactors will be in a very big size, right, which are not compatible in the companies, whereas these nuclear reactors, the small modular reactors which works on the principle of nuclear reactors, are designed in the form of very short, small and compatible, which can be placed in the companies. Okay, see, now let's see the core definition of it. Okay, nuclear fission reactors with a power generation capacity of up to 300 megawatts of electricity per module, means the conventional large reactor generates 700 to 1000 megawatts, 1000 plus megawatts, like the larger nuclear fission reactors. Basically now this nuclear fission reactors, they create how much? 300 megawatts per module they can create. Okay, see the advantages of these modular advantages. Unlike traditional reactors, means the big size reactors which are built on site over 10 to 15 years, which are built on site, to building only it takes 10 to 15 years basically. So the SMR components are prefabricated in factories. They are already prefabricated, means pre-manufactured in the factories and transported by road or ship to the installation site. Wherever the installation is required, these manufactured parts would be transferred. Okay, this reduces the construction time to just 3 to 5 years. Basically, for a nuclear fission reactor to build the traditional model, it requires 10 to 15 years. However, this generates electricity more comparative to this. It generates basically from 700 to, this generates around 700 to 1000 megawatts, whereas this generates 300 megawatts of capacity. Okay, next. These are few. Next, coming to the passive safety systems, they rely on natural forces. They rely on natural forces like gravity, natural circulation and convection, rather than active mechanical pumps. Rather than using the active mechanical pumps like turbines to cool the reactor in emergencies, requiring zero human interventions. It requires zero human interventions to safely shut down. Okay, next, coming to refueling of the machine. How? While conventional reactors need refueling every 1 to 2 years. For every 1 to 2 years, these conventional reactors have to be refueled. But SMRs only require refueling every 3 to 7 years. For every 3 to 7 years, refueling is required, not like conventional ones like 1 to 2 years. Next, coming to the Indian context and recent developments in 2025 and 2026, the nuclear energy mission. The nuclear energy mission, which is released in the budget 2025 to 26 year, okay, which is launched with a budget of 20,000 crores, which strictly for the research, development and deployment of SMR, small modular reactors. Next, see. What is the national target of it? We have seen the Indian target. Now we will see the national target. What is it? Nationally, India aims to have at least 5 indigenously designed SRMs. India needs 5 indigenously designed SRMs operationally by 2033. By 2033, India has to have 5 SRMs. Okay. And reach a total nuclear capacity of 100 gigawatt, to reach a nuclear capacity of 100 gigawatt by 2047, that is the year of Vikshit Bharat.
Okay, next. The Shanti Act 2025. The Shanti Act, what is it? It is the Sustainable Harnessing and Advancement of Nuclear Energy. The Sustainable Harnessing and Advancement of Nuclear Energy for Transforming India Act was recently passed by the Parliament. This was recently passed by the Parliament to SRMs and private participation to modernize India's nuclear legal framework, to modernize the India's nuclear legal framework and allow easier deployment of SRMs and private partnership. This is about the Shanti Act 2025, which is released recently in the Parliament. Okay, now let's see India's indigenous SRM models, which is developed by BARC and NPCIL. Okay. So, memorize the specific models, their capacities and their processed sites. It will be helpful. Okay. BSMR 200. The first one is BSMR 200, which is Bharat Small Modular Reactor. Bharat Small Modular Reactor with a capacity of 200 megawatts. Okay. 200 megawatts. Now, where it is proposed, the proposed site of BSMR 200 is Tarapur Atomic Power Station. Tarapur Atomic Power Station, which is in Maharashtra. What is the application of this reactor? The capital power for energy intensive industries like steel, cement and iron, and these repurposing retiring coal plants. This is the main application of BSMR 200. Next, coming to SMR 55. The second thing is SMR 55, which capacity of 55 megawatts. Where is the proposed site of it? The proposed site is the same, Tarapur, Maharashtra. Tarapur Atomic Power Station, Maharashtra. What is the application of it? It is designed specifically to provide power to remote off-grid locations. Okay, next comes the HTGCR, high temperature gas cooled reactor. When with the capacity of how much it's being developed? It's being developed up to 5 megawatts. Okay, 5 megawatts, which is thermal. Which is the proposed site for it? The proposed site is BARC, Vizag, Andhra Pradesh. Okay, what is the application? What main application of it is? Meant specifically for green hydrogen generation to decarbonize the transport sector. In the sense to stop the emissions, carbon dioxide emissions from the transportation sector, not just electricity. Okay, not just electricity. It's been take up a big challenge of decarbonizing the transport sector. Next, see the few UPSC traps we could see, like SMRs versus BSRs. See, examiners must often mix these two terms in the statement based questions, and they can ask few questions with it. Okay, now see SMRs are small modular reactors, entirely new factory built modular designs. These are modular designs like the BSMR 200, which we discussed earlier. Okay, next BSRs are Bharat small reactors. These are not modular in nature. They are simply scaled down versions. These are the scaled down versions of India's existing traditional pressurized heavy water reactors technology. This is the scaled down version of India's existing traditional pressurized heavy water reactor technology, which is typically 220 megawatt units has been produced and upgraded for industrial decarbonization. This is upgraded for industrial decarbonization. These two you have to have a note on it, because in UPSC the examiner might trick you with these words in statement based questions. Okay, next. Moving forward, let's see the global status and geopolitics of these SMRs. See, the global operational SMRs are, as of early 2026, very few SMRs are actually operational worldwide. The two most notable are, one is Russia's Akademik Lomonosov. Russia's academic Lomonosov, a floating machine SMR, a floating machine SMR, and China's HTRPM. And China's HTRPM. These two are the notable ones as of early 2026. Next, coming to the brownfield development of deployment of this SMRs, a major strategic advantage of SMRs is that they can be installed directly on the sites of decommissioned thermal power plants. They can be, please concentrate on it. This is SMRs is they can be installed directly on the sites of decommissioned thermal power plants. Okay, this saves maximum capital by utilizing the pre-existing grid transmission. They can replace the pre-existing grid transmission lines, water cooling, infrastructure, and railway connectivity. They can utilize all these things because most of the thermal power plants have been closed, right? There have been so many thermal plants which have been decommissioned. By installing these SMRs in that place, we can obviously, basically for a thermal plant to run, they used to have this transport like railways, what you call this infrastructure, water cooling machines, and this grid transmission lines. Generally all these are there, so there is no need of building it a complete new one. So basically they can use, that's why it is named brownfield deployment. Okay, now coming to technological classifications which are related to science and tech, they are light water reactors. The most common SMR designed globally. Based on the light water reactors technology only, most of the SMRs are designed globally, and the base for India is SMR 55. SMR 55 is designed based on light water reactors. Next, molten salt reactors. Molten salt reactors uses molten fluoride or chloride salts as both of the coolants, as both the coolants and the fuel carriers. They are used as coolant carrier and fuel carriers. Okay, now have a note of it. Micro reactors, these are the subset of SMRs. These are again the subset of SMRs. SMRs only the subset of the conventional the conventional nuclear reactors, but now the subset of SMRs are the micro reactors, which are designed to generate up to 10 megawatts of energy, that is small enough to be transported on a single semi truck. In a single semi truck, these are easily be transportable. Okay, this is very important. Okay, next, moving on to the next topic. Our next topic is waste to wealth technology. Waste to wealth technology. Okay, so what is the core institution and framework of this mission is, generally UPSC might ask you test the administrative backing and initiatives of this mission, scientific initiatives, so please have a look on it. Waste to wealth mission. This is one of the 9 national missions directed by the Prime Minister's Science, Technology and Innovation Advisory Council, PMSTIAC. This is the one of the 9th mission. Okay, out of these things, this is one of the 9th national mission directed by Prime Minister Science, Technology and Innovation Advisory Council. Okay, what is the implementing body of this mission is the Office of Principal Scientific Advisor, which is the implementing body. What is the main objective of this mission? Every mission has an objective, right? For this mission, it is to identify, test and validate technologies, and validate the technologies that recover value from waste, heavily focusing on circular economy principles. Okay, next, coming to Swachh Bharat mission, which is in urban areas 2.0. Swachh Bharat mission in urban areas 2.0. It is a major component in it is the mandatory remediation of all legacy landfalls in India through biomining and bioremediation to recover valuable land and resources, waste to wealth technologies. Okay, This is in Swachh Bharat Mission Urban 2.0. All the waste has to be converted into wealth. Next, the high yielding biological and chemical technologies. Please have a look on it. Okay. The conceptual differences between disposal or conversion methods, disposable method, dispose methods or conversion methods can be asked in the UPSC examination in a statement based manner. Okay. So, see, biomethanation, that is an anaerobic digestion, means what is the process? The microorganisms, microorganisms which are responsible to biodegrade, to break down the biodegradable material in the absence of oxygen. Generally we can see, like when it is mentioned anaerobic condition, anaerobic condition is in the absence of oxygen, where aerobic condition is where the oxygen is present during the process. This is what the difference is. See, microorganisms break down biodegradable material in the absence of oxygen. This is what is biomethanation in anaerobic digestion means. What is the output of it? A biogas is produced. What is produced? A biogas, which is primarily methane and carbon dioxide. Carbon dioxide and nutrient rich digestate is also produced, that is used as a fertilizer for many crops. Okay. Next. Now coming to this pyrolysis gasification process, this is generally will be a UPSC trap, because there is no much difference between this pyrolysis and gasification concepts, because a very less difference, use of oxygen and not using of oxygen is the basic main difference. So examiner might trick you in the statement based questions of this. Okay. Now let's see what is pyrolysis. Pyrolysis is the thermal degradation of waste. Basically these two, gasification or pyrolysis, is used for degrading the waste only. Okay. Now thermal degeneration of waste like plastics or biomasses at a high temperatures of 300 to 800 degrees centigrade. Okay, in the complete absence of oxygen. Okay, it produces what? It produces bio-oil, biochar and synthetic gas have been produced by this. You can see this here. See, this is the biomass in pyrolysis, which is subjected to heat. At what temperatures? From 400 to 600, or else from 300 to 800 degrees centigrade, which gives the synthetic gas, a biogas and a biochar is being reduced. Absence of oxygen, this is the key point in pyrolysis. Now coming to gasification, gasification is also heating of waste at even high temperatures, that is more than 700 degrees we are using here, and a few with a controlled or limited amount of oxygen is being used in the gasification process. Okay. So it does not burn the waste, but react with it to produce primarily synthetic gas. Okay, what is this synthetic gas now? It is a mix of carbon monoxide and hydrogen, which is an excellent fuel. Okay, you can see it here. See, this biomass is subjected to temperature heat more than 800 degrees centigrade is being used with a controlled amount of oxygen, which releases the synthetic gas and few ashes of it. Okay, now and another technique is plasma arc gasification. This is mainly used in this municipal solid waste and hazardous waste, whatever is there, it is highly relevant for that. Okay, and it uses a plasma torch. Okay, consider this is a plasma torch from which high amount of heat, like more than 3000 to 7000 degrees centigrade of heat is released in it. Compare 800, where is 800 degrees and where is 3000 to 700 degrees of heat is being released, and that complete is municipal solid waste and this hazardous waste and everything are subjected to that heat, and they get they get degraded. Okay, this waste gets degraded using this high temperatures in plasma arc gasification. Okay, let's see the key advantages of it. It completely breaks down complex toxic molecules into basic elements. It basically what you say, solid waste management of municipality, how much waste it would have, how many different aspects of waste would be there in that, and so many hazardous waste will also be there. From them, it breaks down complex toxic molecules into simple basic elements. The inert gas like byproduct like vertified slag is completely non-leaching and is used safely in road constructions. This can be used in road constructions. Okay, and there are few microbial fuel cells like, see, bioelectrochemical systems. The bioelectrochemical systems that use live bacteria, that uses the live bacteria to oxidize organic matter, like wastewater or agricultural runoff. And convert chemical energy into electricity. Basically, this microbial fuel cells are used to convert this chemical energy directly into what? Electricity. Okay, this is what the main function is. By using what? By using a specific bacteria, okay, which oxidizes the organic matter. Okay, now see the key government schemes. There are few key government schemes where in UPSC they can ask, like, match the following manner. Okay, even in statement based questions also they can ask. See, Gobardhan scheme. This is galvanizing organic bio-agro resources done. Okay, see, what is the nodal ministry of this? The Ministry of Jal Shakti, which is in Department of Drinking Water and Sanitation. Ministry of Jal Shakti is involved in Gobardhan scheme. Okay, it generally do not confuse with Ministry of EFCC or Ministry of Renewable Energy. Don't confuse with this. Okay. And what is the functions of it? The functions is it supports villages in safely managing the cattle during cattle dung and solid waste by converting them into compressed biogas. By using animal cattle dung and solid waste, we can convert it into biogas. Okay, these villages have been supported by the Gobardhan scheme, and organic manure can be prepared out of it. Okay. Next is STAT initiative. SAT initiative, that is sustainable alternative towards affordable transportation. Which nodal ministry is working in it? Ministry of Petroleum and Natural Gas. What are the functions of it? Public sector, it is a public sector undertaking. Oil marketing companies invite private entrepreneurs to set up CBG plants. Okay, CBG plants using agricultural residues, cattle dung and MSW, municipal solid waste, and guarantee the offtake of the produced gas for automotive use. These private enterprises were invited to develop these natural gases. These natural gases will be purchased by the government to give for automotive use. Okay. Next the co-processing in cement kilns. Like the Central Pollution Control Board. The Central Pollution Control Board heavily promotes this because non-recyclable plastic and industrial hazardous wastes. Non-recyclable plastic and industrial hazardous wastes are fed directly into cement kilns. Like the extreme heat, like around 1400 degrees centigrade is applicable and completely destroys the waste. It completely destroys the waste without leaving ash. This replacing the need for conventional coal. Next, we have e-waste and emerging concerns. What are these? Urban mining. In urban mining is the process of
extracting precious metals like gold, silver, palladium, copper and etc. from discarded electronic waste. Generally our electronic waste, the e-waste what we use, mobiles, what you call the laptops, the systems, the TVs, whatever are there, from that e-waste we can get a few precious metals like gold, silver, palladium, copper etc. Okay. So this e-waste contains deposits of these metals. Okay. They are 40 to 50 times richer than natural ores mined from the earth. Okay. This is the urban mining. Then e-waste management rules 2022. This e-waste management rules 2022, this introduced the mandatory extended producer responsibility. The mandatory extended producer responsibility framework has been introduced by e-waste management rules 2022. The producers are now legally bound to ensure the collection and recycling of specific percentage of the electronic goods they introduce into the market, which are being introduced into the market. Okay. So moving on to the next topic, that is microbial fuel cells. What are these microbial fuel cells now? This is a bioelectric chemical system that drives an electric current. What is it? It drives the electric current by using microorganisms like bacteria, okay, as catalyst to oxidize the organic matter into inorganic matter. Converts the organic matter into inorganic matter. By using what? By using a bacteria, basically microorganisms. Okay. See, the electrogens. What are these electrogens? These specific types of bacteria, the specific types of bacteria which are used in MFCs. These are the specific type of bacteria which are used in MFCs are called exoelectrogens. Exoelectrogens, okay, or electroactive bacteria. These are also called as electroactive bacteria. And these common examples which are tested generally in the exams, those are include Geobacter and Shevanella, okay, Geobacter and Shevanella. These bacteria have the unique ability to transfer electrons outside their cells. Basically, see, this microbial fuel cells has a two-chamber setup. One is the anaerobic chamber and another is the aerobic chamber. Anaerobic chamber where the oxygen is absent, and in the aerobic chamber oxygen is present, where the substrates are converted into carbon dioxide, and here taking the oxygen it giving water. Okay, this is setup of MFCs. Next, how it works, let's see. We have a anode chamber where oxygen is absent, that is anaerobic condition. Okay, what happens in this? The bacteria feeds on organic waste, like what? Like wastewater. Okay, and as they digest the waste, they releases electrons. They releases the electrons and protons into that chamber. Okay, in which conditions? In the absence of oxygen, that is called the anaerobic condition. Okay, next, the circuit. The circuit means these electrons and protons which are produced in this chamber, they are travel through an external wire. They travels through an external wire from the anode to the cathode. Anode to cathode means the positive charge to the negative charge, so that the electricity is generated. So this is of electrons. Now the protons, what happens to the protons which have been generated? These protons travel to a proton exchange membrane. Proton exchange membrane which is separating the two chambers. You can see it here, which separates, this is one chamber of anode and anaerobic chamber and aerobic chamber, and anode to cathode, this is been traveling. Electrons are being traveled to generate the electricity. Okay. Next, see, the cathode chamber where oxygen is in rich quantity, means in the condition of aerobic conditions, where electrons and protons and the oxygen, electrons, protons and the oxygen combine to form pure water as the only byproduct. Okay, basically what is it? Converting wastewater into the normal pure water by producing electrons and protons. Okay, next. Sorry, coming to the strategic applications. See, in stimulus wastewater treatment and power generation, it is being used. This is the most crucial application. Instead of using massive amounts of electricity, to run water treatment plants, generally we need more amount of electricity. MFC uses the sewage itself. It uses sewage itself to as a fuel to generate electricity while purifying the water. Basically, more amount of energy, more amount of electricity is required in water treatment plants. To reduce that water consumption, if we use MFCs what they do, they use directly fuel. They use directly sewage as its fuel to generate the electricity while purifying the water. This is the use of MFC in simultaneous wastewater treatment and power generation. Next, biological oxygen demand, BOD. These are in biosensors. Like MFCs can be used as a highly sensitive real-time sensors, to measure organic pollution levels, in rivers and lakes. Okay. The electrical current which is generated is directly proportional to the amount of organic waste in the water. Means, see, the electrical current which is generated is directly proportional to the amount of organic waste in water. This is how we can calculate the BOD by using MFCs. Okay. Next, in remote power sources. How are these MFCs are used? These are used to power deep water marine sensors. Or telemetry systems where replacing traditional batteries is impossible. Replacing the batteries is very impossible. The task is, the bacteria simply it feeds on the organic matter and in the ocean sediments, and it converts into the organic matter. This is what it is benefited by MFCs. Okay, these are few strategic applications we have to look into the MFCs. Next, we can see few differences like MFCs, MECs and high hydrogen fuel cells. Okay. See, examiner might trap you in these questions in the statement based manner, so please have a look on it. When we see traditional fuel cell, that is the hydrogen fuel cell, which uses hydrogen and oxygen gas to generate the electricity and water. Okay, it does not involve any living organisms in this. Okay. And coming to microbial fuel cells, what happened? The inorganic, by using bacteria, the organic waste to produce electricity and water. It uses bacteria and organic waste to produce electricity and water in the MFCs. In microbial electrolysis, what happens in microbial electrolysis cells? A closely related technology instead of producing electricity. And MEC requires a small input of external electricity to force the bacteria. It forces the bacteria, but in MFC it doesn't force any bacteria, it just introduces the bacteria. This bacteria itself converts this inorganic matter into organic matter, which now thus leads to the generation of electricity, but not in the case of MECs. MECs, what they require? They require a small input of external electricity. They basically have to induce some electricity to the bacteria to produce pure hydrogen gas from the organic waste. These are the three differences. Basically in this hydrogen fuel cells, no bacteria is used. Generally what you called hydrogen and oxygen is used to produce the electricity and water. In MFCs we use the bacteria which uses organic matter to convert into electricity, to purify the water, electricity and water. Next, in MECs what happens? Initial electricity has to be produced to the bacteria so that It produces pure hydrogen gas from the organic waste. So, make a note of these differences because in statement wise questions you can get these terms. Okay, next. There are few current limitations and bottlenecks for this MFCs. We will look into it. Low power density. This is the one major concern where while highly sustainable, the actual electrical output, electric output is currently too low. It is too low for large scale commercial grid integration. Okay, they generate microwatts. They generate only microwatts or milliwatts, which are enough for sensors but not for heavy machinery. The electricity which is generated by the MFCs are not that much useful for heavy machineries and all. They are basically used for the small sensors and all. Okay, now next is the high material cost. Basically the MFCs needs a very high material which are in very costly. The proton exchange membranes, okay, the proton exchange membranes like naphion and the platinum often used as a catalyst. Basically the platinum is used as a catalyst in this process. So on the cathode and are extremely expensive. These are extremely expensive, hindering mass deployment in developing nations. This is one of the major bottleneck problem. Next is biofouling. Biofouling is over time dead bacteria and debris. The bacteria cannot live for too long, right? We can't preserve the bacteria for that long time. So over time the dead bacteria and debris can clog the membrane. The membrane can be clogged by it by reducing the efficiency of the cell. Okay, this is another drawback. These are few limitations and bottleneck problems of MFCs. Okay, next. Let's see few intersecting government policies. What is it? First one is biotechnology for economy, environment and employment, that is Bio E3 policy, which we have learnt in last 2 classes before, I think so. So have a look on it. So recently approved by the which cabinet? By the Union Cabinet. This policy strongly pushes for high performance biomanufacturing and bioprocesses. Okay, these MFCs fall directly under the policy mandate to support climate resilient agriculture and environmental conservation technologies. Okay, next, Namami Gange and Swachh Bharat. Namami Gange and Swachh Bharat. This MFCs research receives institutional funding. These MFCs receives the institutional funding to find decentralized low cost ways to treat sewage before it enters major river systems. Before entering the major river system, the sewage is being treated by MFCs. For this, the financial funding has been released, aligning with national sanitation missions. Okay, these are few government related policies. Now, okay, so these are the topic for today. And if you wanted a detailed note of this video, please do visit our website and download the note from there, and do follow our YouTube channel, do subscribe and do like and share this video and for your UPSC preparation, and do follow our Telegram channel and Instagram channel also. All the links are provided in the description box below. Please do find, and I'll see you all tomorrow with another session. Thank you.